All right, folks, we are going to be working on the counting chickens exercise here. And, they give you a little heads up here that chickens is already basically an array of chickens that was already built for you. So, and if you want to examine that, of course, you can just hit the little thing here and you can see all the features of those chickens, right? And you can also look at it this way if that's a little easier for you. I tend to like this approach because I can look at the whole list, where this other approach here, this one gets a little cut off, right? So I can't see the stuff that's below. Oh no, actually I can. Okay, so I have to click on it first. All right, either one works well. Oh, so I'll give kudos to Xcode there for making sure it does work well in both environments. All right, so it says the chickens are all hatched, so it's safe to count them. And we can do that really pretty simply. So we set up a variable for the count, set it to 0. Then we run a for loop that loops through the array structure, reads in each chicken, and for each one of them that it cycles through, it adds 1 to the counter, and then we output it, and you can see the output is 20, which it should be, right? The challenge for this exercise is as follows. It says, update the code for the for in loop to only count interesting chickens like hilarious leghorns, right? Then basically add to the total, just counting those, right? So if you look at the list above, and I think this is a good place to start, right? So we are looking for hilarious, right, as a thing. And I'm noticing that hilarious is attached to Leghorn here in Rhode Island here. And they're giving here a suggestion, and this is open to interpretation, by the way, because when I look at the aspect of this that I want to consider, I could make a count of leghorns or hilarious, right? And it's all in the reading of it. I did notice a really kind of interesting thing though. This, leghorns can be friendly, grumpy, hilarious. There's not too many chickens here that are hilarious. 2 out of the 3 tend to be leghorns. So do I, I'm kind of thinking, do I even need to check for leghorns, or should I just check for hilarious? And I can tell you what the author did is they just checked for hilarious, by the way. Now, this is really easy to ramp up. So the way that I'm going to do it is I'm just going to write an if statement, and I'm going to say, if the chicken dot temper, right? So that's the temperament, is equivalent to dot hilarious, right? And so we kind of like, and I'll tell you what happens to me is when I look at this code, I forget, like, oh yeah, that dot hilarious is like that because it's basically a property, right? It's a property of the temperament of this this chicken. And whenever that temperament equals hilarious, that's when I will add to the count. So instead of just counting every chicken, I'm only going to count it if it's hilarious. Right? And this is the way the author did this. Now, what do you guys think about this? Do you think this is a complete solution? According to the author, it is. And now, I real frankly, when I saw this description, it like hilarious leghorns. Okay, so that to me is 2 questions. I don't know if you guys read it that way, right? So what you may have done is you may have said if the temper is hilarious, and then you could nest another if. So you could say if chicken dot breed equals dot leghorn. So you could have taken it 1 step further and then moved this statement into a second if statement. So if it's hilarious and if it's a leghorn, then it would register. So now I think that this is a more correct answer given the information they provided us. And I don't know if you guys did it like this, right? But
I didn't do it like that. I did it kind of like how the author said to.
Okay. So how did so you just did it the first way, you just counted the hilarious?
I did, yeah.
Okay.
So I just counted hilarious. Or
Yeah, and I
no,
think
I'm
that
in Leghorn. I counted Leghorn. Sorry.
okay, and you know what? You can really read it a bunch of different ways. You know, the point is to understand how to access the information, because
Hmm.
we do have basically this array of chicken objects. You know, if you want to think of them like that, or chicken types. Those chicken types have both a breed and a temper associated to them when they're created. We can test for both of those properties. It carries with the object. So what logic check you really do inside this statement is really kind of up to you, right? Um, I think, you know, you could have easily picked one or the other. I'm reading this pretty clearly as like a hilarious Leghorns. And so I checked exactly in that order. So if I check for both of those things, there's two of them. I confirmed that visually before. If I'm just checking
Hmm.
for hilarious, there's three of them. And I would say that either answer is fine, right? This would be really easy to change, of course, if you wanted to check for something else. You just alter your if statements and you're all set to go. All right. Any questions on that? Can I move forward?
No, it's good.
Let's
Yeah,
go on
go
to
ahead.
the next exercise here. This next one is slightly more complicated, but maybe not as much as you might think, right? It says the following struct describes a type of enemy in a game, right? So this is always like, you know, thinking like game players, right? And
Hmm.
here's let's just check out the struct they have. So we have a struct called enemy, and there are looks like three properties in there. One is strength, which is an integer, speed, also an integer, and then a weapon, which is a Boolean, so true or false. Now, we are asked at next, as your game is developed, you've decided that your enemies might have more than one type of weapon. This is kind of an interesting thing. So not whether or not it's true or false, you know, so maybe like the basic weapon is a sword, you know, like who knows, you know, like whatever the game is. And it says here, define an enum to represent the weapons an enemy might have. For example, none, a sword, a rubber mallet, and so on. So you could embellish that, right? And then change the struct definition to use your new enum instead of a Boolean. All right, so let's do that. So here's how I will accomplish this. Now, I thought I would pause this video, but I think instead, let's just go ahead and code it. So let's define enum. This is an object, basically. So we're starting with a capital letter. And then we could define three different cases for this or more, right? But I'm just looking at the list they have below. So the one might be a sword. Another case might be a rubber mallet. I'm not sure how useful that would be in a fight, but and then if you want to, you know, throw in a gun, a knife, you know, whatever, you know, you throw in your stuff. But I'm just going to go with the three that they have listed there. So basically, the three cases that they have are sword, rubber mallet, and none. Okay. Now, for us to be able to use that data here in our struct, we already have a property called weapon, and it's of type Boolean. Now, here's the cool thing you have to remember about using enums, right? We're basically creating a new object type, really a new data type is really what we're creating. So we could just simply replace this here with the object name of weapon with the capital W. And that means that what goes in this spot for this enemy would be one of the weapon options from above. They either have nothing, a sword, or a rubber mallet. And of course, if I added to this list, you know, for example, if I added like gun, you know, knife, nuclear bomb, you know, whatever that happens to be, you know, and I'm being a little goofy now, but any of those would be valid weapons that could go into that spot. We're not dictating which one it is, but these are the possibilities for that particular thing, because we're pulling in basically, and this is a good way to think of it, a custom data type called weapon that we created that has all these different cases or possibilities. Right. And this is a pretty simple solution. I'm going to pause the video here and see if you guys have any questions. All right, we're now going to move on to the next exercise here. That one was actually, I think, fairly simple. And the first thing that you'll notice this next one is there is a whole bunch of data that's provided with it. And that's done intentionally, so you don't have to create it. Okay, but let's take a look at the description here, and then we'll figure out how to code it. So, all right, it says, in the arrays and loops playground, you had a chance to create a function that would tally votes from classmates. At the time, you could only ask yes/no questions that could be held in Boolean results. You were worried that using strings would result in voting mistakes from typos, but now that you've studied enums, you can safely make your voting system a little more sophisticated. And actually, this is really kind of a good case in point. I was making the same point yesterday during my web class when I was teaching people how to create drop-down boxes. And drop-down boxes are a great option for programs because it eliminates the possibility that somebody's going to type the wrong thing. They just select it from a list, and then the data is correct, right? So it ensures data integrity is really kind of the way to say it. All right, so let's first take a look at the enum. So the enum has two cases attached to it, which is beach and chocolate factory. So those are the two things. And then we have this other structure here, which is let trip destination votes equal, but basically the type, which is an array of square bracketed items here. All right. So in other words, we are looking at an array of these enums. Hopefully that kind of resonates. Okay, so we have an array of those. And then when you look at what's on the other side of the equal sign, you see the square brackets, and then you see all the comma separated values, and really what these are basically are the votes, right? So they're voting either beach or chocolate factory, and you can see the whole thing is basically beach chocolate factory all the way through. There's 200 of them if you want to count, right? Probably don't have to. And it says, without counting the votes by hand, right? And this is the whole point we do the code, right? Find out whether students prefer the chocolate factory or the beach. And the hint is, check the arrays and loops playground for a refresher on working with collections of data. All right, so here's what I'm gonna do. I'm gonna pause the video for a second, and then we're gonna go look at that code and see if we can refresh it. All right, so I'm gonna pause for a moment. All right, so let's start out here by first setting up a couple of variables that are going to keep track of the vote, right? So, and variables would be important because want to change this value as we count. So we'll preset beach votes to 0 and factory so 0. Now we have a starting point. The next thing that we want to do is we want to traverse this array structure above, and that sounds like a job for a loop, right? And we've learned how to do this, so let's create a simple for loop, and we got to think of like what we're going to call each thing in there. Well, it's a destination, so I'm just going to abbreviate and say dest. So for each destination in trip destination votes, right? Then for me, we are going to loop through and check. Now, the point of this one is to use a switch and case statement, right, to get practice with that. So we'll start out with switch. And what are we switching on? The destination that we're currently reading in from the array. And then if the case is beach, then beach votes will well, plus equal 1. So we're going to add 1 to that total. Right. Then, if the case is chocolate factory, then we're going to add 1 to the factory votes. Plus equals 1 on that. So that's just going to process it really quickly. And you know what? You can already see the results right in the sidebar, right? If you see that, so it looks like 110 for beach votes and 90 for factory votes. I'm surprised the factory got the that high. You know, like I'd rather go to the beach any day over that. Now the other aspect of this is okay. Well, I guess we can see the results, but it's not really telling us anything, right? And really, to get a message on the screen that might be useful to the user, what would be smart is we can just write an if statement to do some output that would be helpful for the user. So for example, I could say if the beach votes are greater than the factory votes, let's just do a little output and say print going to the beach. Sounds wonderful. Otherwise, we have a different condition to check. So here we can say else if the beach votes are less than the factory votes. We'll just print out a simple, what should we say here? We're going to the chocolate factory. Well, I guess I can kind of see the appeal of that. If you like chocolate, you're good, right? Have you guys ever visited Burlington?
No, over by where the Hershey factory is.
Nestle, actually.
Nestle, that's it.
Yeah, there's times when I taught out there, and there are days when the wind's blowing the right direction, but the whole city smells like chocolate, by the way.
It does. I've been there a few times. Yeah.
Kind of an enticing, intoxicating smell.
It really is.
And so you see what I'm doing here is I'm also putting in a third scenario, because what if they turned out to be a tie? So like you might not think about that scenario. Now I might also think that it's useful, by the way, that you maybe output how many votes there were, you know, and that's subjective, right? Because we're already seeing the results. But here's kind of the larger question here. Why is the switch statement a good choice here, but not here? Why couldn't I use a switch statement here? You guys remember the reason for that?
Let's think about that. Well,
Isn't it more of like declaring like those votes have already been certified? So since the votes have been certified, the if is more like declaring like, hey, beach vote to one. This is what we're doing. That's how I'm interpreting it as.
Okay, so Jeremiah, you're kind of on the right track, but not quite.
Yeah.
well, is it because the switch case iterates through each one individually, whereas the if statement goes through the end results?
Well, the if statement does go through the end results, but like,
Mhm.
you know, for example, you know, I could have wrote an if statement and put it in here instead of a switch, right? But switches and enums work well together because the cases are kind of locked in, right? There's only so many cases, and they have to be precisely that. The other thing I can't do in a case statement, by the way, is do comparative logic. So I can't use
Oh,
greater than
okay.
or less than, or you know, check for equivalency. I'm just checking for its state, and then depending on its state, I take a course of action. Where here, I can actually check for value. So like if, you know, for example, I went up here and I edited this list and let's say cut out, you know, like all those and ran it, the results might be different and that logic might flip. But I can't test for logic in here. So I can't say if beach is greater than chocolate factory, add one, right? I mean, that's not a real comparative, but that's kind of the larger point here is you can't really do comparative logic here. You're just checking for a particular state. Here's kind of another exercise here that's built into the bottom part of this, right? Like if one exercise isn't enough. And then this one says, in another poll for choosing a school mascot, you decide to add an undecided option, right? So like if, you know, the mascot options are salamander, marmot, okay, whatever. You could have either one of those as a mascot, but, or neither, right? You don't want either one of those, right? Now we are importing a foundation here that, you know, we've talked about that before. It's just a library that we're using here. Now, part of this is we do need to determine, once again, which one won. So we're going to follow a very similar technique to do it. Variables for counters and a switch case statement to count the votes. And then we're going to do a little bit of, once again, comparative logic to see which one won, right? So let's just go ahead and do that. And so just looking at a spot here to type my code. I'm probably just going to type my code right here at the bottom. That's probably a good spot. Let's create the variables. So first, we'll create 3 variables, and for efficiency's sake here, I am copy pasting. I consider that a little cheating, but hey, that's my option as a teacher, I guess. All right, to speed it up. So 1 variable for each one of the options, right? So salamander, marmot, and neither, right? So all of those are being counted. Then we'll run a loop, right? I do want to look at the names here. So this is called mascot votes. Let me say for mascot in mascot votes. We'll loop. We'll set up our switch. What are we checking? Each individual mascot vote. And then we'll start setting up the cases, right? So one case is salamander. And I like how that, you know, like automatically finds it for you. I think that's really cool.
That is nice.
Oh, so salamander votes. And then we have another case for, was it marmot?
Yep.
Marmot votes plus equals 1. Right, so the logic on this is not really any different than what we did before. You guys can see that. And then, you know, it's just kind of, at this point, kind of a mechanical process once you see how it works, right? So this will tally the votes. We can see the results already in the sidebar, and it looks like salamander is the winner, okay? And I guess I'm not even sure what a marmot looks like, but I suppose we can Google it. Yeah, salamander is probably a little bit cooler than a marmot. That's what I'm guessing. So now we have to do a little bit of logic to determine which one won, right? And so here comes the if statements. Now, here's the difference on this one. Before we had 2 that we were checking. Now we have 3. Would this be a situation where we could use a switch statement again? And the answer is going to be, now, given what we already did, the answer is no. Right? We have to use comparative logic to figure out who won. So we're just going to get really kind of simple here. I'm going to give you the first part of the if statement, and then I'll paste in the rest. So here's the first part. So I'm just going to say simply, if the salamander votes is greater than marmot's and the salamander votes is greater than neither vote, then salamanders are the new mascot. Then we can do an else if to check the other animal scenario, which is the marmot, which would look like this. So if the marmot's better than salamander and marmot's more than neither, that one wins. And these are both ands, by the way, logical ands. So compound statements. Otherwise, just in case, neither animal won, if you think about it, it doesn't really matter if most people voted for neither, or if maybe they happen to tie, right? The animals happen to tie. This would catch every other scenario, right? So there's either a tie or neither took over and succeeded. So that's what I have as a solution for this. So I'm just going to scroll up on that a little bit. Now, the thing that I'm going to mention here is they have this little experiment here that they mention at the bottom. So it's worthy of talking about at least. And it says, in the arrays and loops vote counting exercise, an extension exercise asks you to write a single function that could calculate the results of any Boolean vote. What prevents you from writing a single function for calculating both trip destination votes and mascot votes, right? And here's, I'm just going to paste this in. This is the answer from the author. So I'm just going to list that. I guess it doesn't really matter where I put it. I guess I'll put it up here because I have a little code spot. I'm putting it in the form of a comment. So this is the answer to that experiment. Because you have to create a var for each option you're going to tally. Trips have 2 options for vote. Mascots have 3 options for vote. Inside our function, we can't create different amounts of variables, right? That's the one reason, basically. But we're counting a different number of things, and we're counting specific things as well, right? So a generic vote counting thing is not necessarily applicable here. That's kind of the grand. All right, those are the solutions for this particular exercise. So these are the exercises that are at the end of the enums here. Now, I'm going to pause the recording here for a second. All right. From here, we're going to go on to build the bouncy ball app. So the video solutions for the enums and switch playground is now complete. So this video ends here.